Welcome to this course on 2D game programming. I'm Tom Robertson. I'll be your instructor. I have a little over a decade of experience working in the video game industry, as well as more than a decade of working as an indie game developer, selling video games on the internet. I've been programming since I was 13, and all I've ever wanted to do when I was programming was make video games. I was never very interested in making spreadsheets or storing recipes. It's all about video games for me, and I want to share that with you. I'm here to teach you how to program video games. I know that there are different aspects of making video games, including art, story, sound, but I'm a programmer, and I'm going to teach how to program a video game. Now, I expect you already to know how to program. You should have certainly done your first Hello World program. You should understand what an if statement is, what a loop is, input, output, your basic print statements, that kind of thing. And it sure also would be very helpful if you understood the basics of object-oriented programming, because we'll be working with Microsoft Visual C# 2010 Express. I don't expect you to know C# right out of the gate, but since C#, Java, and ActionScript 3 are actually basically the same language, then it shouldn't be hard to pick up. We'll also be working with XNA 4.0, which is Microsoft's game development package. Now, I know that Microsoft has discontinued the use of XNA because they've moved on from the Xbox 360 to the Xbox One. However, you can still get XNA, you can still download it just fine, and it works great. So I'm going to continue to teach that for now. I want to start by downloading and installing Microsoft Visual C# 2010 Express. So let's go to Google and search on it. C#, notice that the sharp symbol, which is Shift 3 on my keyboard, not the word sharp. So C# 2010 Express. And if I search on C# 2010 Express, you can see, let's see here, that first link that I found takes me to exactly the page I want. You can see here, I'll go to Visual C# 2010 Express and choose Install Now. And notice that it gets a little bit of installer, just loads it down so that you can run it and installs the rest of everything. Go ahead and install it on your machine. It'll take a while. Now we'll first install Visual C# 2010 Express and get it working. At least fire it up to make sure that it actually runs. And then we'll also install XNA 4.0. It's a separate download, a separate install. And what we want to do is make sure we install them in order. So Microsoft Visual C# 2010 Express first, and then XNA 4.0. So now I've got my Visual Studio 2010 Express installed. I should fire it up, make sure it works. Yeah, it looks like it does. Alright, so I'll just close it down for now because I still need to download and install XNA 4.0. So go back here to my Google browser and say XNA 4.0. Looks like the first link from Microsoft will lead me to the correct direction. Yeah, this is the website I want to see. I want to hit download. And it downloads a download install package. Once it's finished downloading, we can install it. Right, now that I'm done installing XNA 4.0, I will fire up C# 2010 Express again and make sure I installed correctly. I will choose New Project, and I can choose from installed templates. I can choose Visual C#, but I can also choose XNA Game Studio 4 and make my test program and hit OK. Now what's happening is that Microsoft is actually building a large number of files and setups to make your life easier. It's setting up the entire game at least the framework of the game, to make things as easy as possible. And this is Microsoft's way. Microsoft's attitude when it comes to game developers, or well, software developers, is to do it all for them and make it as easy as possible for them, which is great. It means Microsoft makes great tools for developing software, but it also means that Microsoft tries to do it the Microsoft way. And if you're not willing to do it Microsoft's way, well, suddenly you're out of luck. But for now, we're going to do it Microsoft's way. So here we are, looking at this brand new program that it made for us. I will hit F5, but I can also choose to press the green arrow on the toolbar of this application to start the program. And look, I get a blue screen. It doesn't do anything but give me a blue screen, but I mean, it's working. It's obvious that I've managed to make my empty project correctly. I'll close it. So let's go over some theory. You probably already know that your computer screen is composed of something called pixels, which are just dots. Your computer screen is a two-dimensional ordered grid of dots. It goes left to right and top to bottom. There's just a squarish grid of dots. And these dots are able to light up in different colors. They go from black to white, and these individual pixels have components. They actually come in 3 different pieces. There's red, green, and blue. These 4 colors are the basic colors that appear on your screen. But for our purposes, when we're thinking about two-dimensional arrays of pixels, which are specifically called bitmaps, we also think of a separate channel or a separate additional component that comes with each pixel, and that's A, or alpha, or translucency. In other words, in a normal bitmap, you have your red, your green, your blue, but you also have your fade, or your how well you can see through that pixel, which is the A, or the alpha channel. So you notice that your screen is not actually translucent at all. That's because your screen is actual pixels and doesn't have the A value. But when we get into painting things on the screen, we'll take art that's in a bitmap format. That's, it's like the screen, it's a two-dimensional array of pixels. But because we want to overlay the bitmaps on top of each other and do so in a way that makes them not look square, we like to have that translucency, that A value. So bitmaps are bitmaps precisely because they're two-dimensional arrays of pixels. And you can edit these bitmaps with basically any editor. I'm a big fan of paint.net, which comes free. You just go and get it, download. Any modern PC, any Windows PC will run it. And it's a good tool for making, modifying, and saving two-dimensional bitmaps. However, here's another great secret of the universe. The entire screen is made up of triangles. That's right. You may think that the screen is made up of pixels, and at a very low level that's quite true, but in the level that we are going to make video games, the truth is that everything's made up of triangles. Now you can look at your screen and say, clearly not, because I don't see many triangles or very many triangle-y things on my computer screen. The reason for that is because what you're looking at is actually textured triangles. In other words, it's triangles onto which a bitmap has been painted. A triangle, which is always 3 points, will have a bitmap stretched over it, much like the skin of a kite is stretched over the skeleton of a kite. The texture is really just a bitmap. The only reason you call it a texture is because it has been stretched across a triangle. This is more important when you get into 3D game programming and you deal with 3D objects. But for now, let's just call them bitmaps. GPUs and CPUs. In all modern computers, the truth is that the computer itself does not make the video screen. The computer has another computer to the side, and that computer's job is to pay attention to the video screen and build it. So you've got the computer, the CPU, and the graphics card, or the graphics chip, called the GPU. and they talk together and they work together very closely, but they're not quite the same thing. And the fact that they're separate is a lot of why doing computer graphics can be so complicated. Not so much for this class. We're going to start out easy, and XNA makes it also pretty easy for us. In general, there's always CPU and GPU in your computer. Something to think about. We are going to make a brand new program called OneLetter. This will be the first teaching program that I'll expect you to follow along with in this series. First thing we want to do with OneLetter is open up our Microsoft Visual C# 2010 Express tool. And we're going to choose New Project from the File menu. We're going to make an XNA Game Studio 4.0 Windows Game 4.0, and we're going to call it OneLetter. So I'm going to change the place that I want this solution to be created in, and I'll hit OK, and as we've seen before, it's going to create a brand new project called OneLetter. I'm just going to run this new program just to make sure that it runs and that I see the blue screen of happiness. And there I do. Alright, now there's a couple of files that you have to get and incorporate into this project. So the download link is just below this video in the comments section, in the notes section. And once you download the zip file containing these two files, I expect you to unzip, unpack the file, and copy the two files, which are .cs files, to the correct location. So let's look at what the correct location is. I'm going to open up here. I'm going to go to my teaching talks. Wrong one. I'm going to go to my teaching talks folder. And here I have my OneLetter base directory. Now this was created for me by the Microsoft tool. And let's look at this directory structure a bit, because we've got OneLetter here, and then if we go inside that, we've also got a OneLetter directory, and we've got an SLN and an SUO file. These are again all built by Microsoft for us. Specifically, this SLN is the key file. This stands for solution, which is Microsoft's term for the whole project. So if you just double click this solution, you can open up the whole project if you want. So let's go inside the other OneLetter directory, and now we see we have another OneLetter directory. Thank you, Microsoft. But we also have a OneLetter content directory, and these two directories are very important. The OneLetter directory here, which is inside OneLetter, is where we're going to put our code, our programming files, which for C#, the C# programming language, end in .cs. So let's look at that. You can see I've got a game1.cs and a program.cs. And they're both, as the pop-up assures us, Visual C# source files. So these two source files are really all we need for this project to begin with. So let's step back out OneLetter to where we have OneLetter and OneLetter content. You can see that we have OneLetter content, and that contains bin and obj and content project and stuff. But the truth is that what it's supposed to contain is all of the art and sound for our game. The content of our game is supposed to go inside this directory. I told you before you had to do it Microsoft's way to make sure that Microsoft's tools make everything smooth and easy for you. And this is an example. This is just the structure that Microsoft decided we would play in. And that's okay, as long as we know. But inside the content subdirectory, it's important that we put all of the files, the sound and the image files that we're going to use for the game. But it's also important to know that Microsoft and its XNA tool set aren't going to use that content directly. They've got their own content importers, as they call them, and converters, as they call them, and they're going to take that data, modify it so that it's only usable by this program, and store it in another directory. And that's why when we start adding content to the game, we find that we not only have to put the files, the content files, into the correct directory, we then also have to expressly add them to the project. And we will add them here on the right side using our Solution Explorer. For now though, what we want to start out with is something simple. We want to get those two files that I mentioned before and copy them into the correct directory. We're going to copy them into OneLetter, OneLetter, OneLetter. The two files that you're going to get out of the zip file are called game1.cs and helper121.cs. Helper121 is extra code that makes life a little easier for you that I wrote. And game1.cs is the starting point for all of your XNA projects. What we're doing is not only downloading and moving a file here, but we're actually copying over the game1.cs that Microsoft made for us. That's okay. I know what I'm doing. Follow along. Notice here that now that I've copied these two files, I actually have 3 CS files in my OneLetter, OneLetter, OneLetter directory. Game1.cs, helper121.cs, and program.cs. I mentioned before that not only do you have to add content to the proper directory, but you have to expressly add it using the Solution Explorer. And that's true for programming files as well. So let's go do that now. I'm going to go to OneLetter here. I'm going to right click. We choose Add Existing Item because the file's already on the disk. And now I can choose Helper121. That's my new file that I want to add. Notice that in your Solution Explorer, game1.cs and program.cs are already there. So let's begin looking at game1.cs for this OneLetter project. Follow along with me line by line. Here at the top of my code, I have my usings where Microsoft XNA is added, and I can use the XNA features because I use the using commands. We've got our defined namespace of OneLetter. Every class or code file in C# will have the same kind of namespace, OneLetter. They're better just to make everything easy on us. Then we've got our game1 class, and inside it we define some variables for the class, some very important variables, our graphics manager, our Spritebatch, which we'll talk about later, and our helper, helper121, which remember we added to the project. So here is our constructor for game1. Of course, that's about object-oriented programming. The constructor, the destructor, the class, the member variables, and the member functions. These are things that you should review if you don't know anything about them. Here's my initialize function, which I'm not actually doing anything with. Here's my load content function. Notice that most of this is done for us, but notice how I added helper. I created a new instance using the new keyword, and then I called the setup function to make sure that helper is properly initialized. Now that I'm not doing anything with the unload content function, you probably won't for a while, because C# is a modern language with what's called garbage collection. Garbage collection allows the program to erase data that you allocated but no longer use or need. In my C and C++ programming, you must deallocate everything you allocate, and it's up to you as the programmer. But more modern languages take care of that for you. Yay, we're living in the future. Here's my update function. Notice a couple of things here. First off, this function assumes a game pad. Obviously we don't have one plugged in. You may have an actual wired game controller plugged into your computer. If that's the case, then when you run this program, the program will stop. The program will exit. This exit stops the program. But this was created for us by Microsoft because, remember, what we're talking about is XNA for the Xbox 360. Microsoft intended for XNA to be used for people who wanted to make games for the Xbox 360. It's very useful to also make games for the PC, and that's why it's so easy for us to use XNA now, even if we don't actually own an Xbox 360. But you will find that throughout the XNA structure is the idea that XNA was specifically designed for both the PC and the Xbox 360, and not really anything more than that. So as you can see, we don't actually do anything here in the update, but that's exactly where most of our game logic will go when we actually make game logic. And here's the draw function. We start by clearing the screen to cornflower blue, and we could easily change it so there's another color, but this is the standard thing that Microsoft starts us off with. Now, in our drawing code, we do 3 lines that Microsoft didn't create for us. We start the Spritebatch and end the Spritebatch around our drawing, and that's important to remember what we're going to do there. We've got to start the Spritebatch and end the Spritebatch. Spritebatch is a terrible name. It should be something like 2D graphics controller or screen settings, because that's really what it is. I have no idea why Microsoft chose to call it Spritebatch. It doesn't actually directly have anything to do with Sprite, and while it can batch, that's kind of not something we have to worry about right now. Basically, Spritebatch is Microsoft's class for helping control the 2D display. And here, using helper, I'm going to draw text. I'm going to use Spritebatch. I'm going to draw the letter A. I'm going to draw it at 200 across by 200 down, and I'm going to draw it in the color white. Let's see if that works. I'm going to hit F. I'm going to actually start the program. Oh no, it doesn't work at all. We've got an error. Well, first off, don't panic. You get errors all the time. It's just something to fix. Let's read the error instruction before we get panicky. Okay, this is a content load exception. File not found on Sprite font 1. So why was the file not found on Spritebatch, Sprite font 1? Well, probably because we didn't actually create a Sprite font 1. So let's do that now. Now let me explain Sprite fonts. Microsoft Sprite font is based on the idea that a font, which is basically a set of letters, can be incorporated in a bitmap, just like we've been talking about, a 2-dimensional array of pixels. And once it's incorporated into the bitmap, then it can be drawn easily on computer screens. What it boils down for us, though, is that we just have the XNA toolkit make a Sprite font for us. So let's do that now. I'm going to go to OneLetter Content, right-click, and add a new item. Now, obviously, I have a few different choices. I'm going to choose Sprite font. And Sprite font 1 is the default. So I don't have to change the name at all. I'll just hit Add. See, down here in Content now, your Sprite font 1 is now added. And if I select it, it tells me more about that Sprite font. But the important thing is now that I've added it, I can try to run the program again to see if it works. Aha, this time it worked, and not only did it work exactly as I programmed it to. See, here's the little white letter A in the center of my screen. Here in our draw function, you can see that we call the function drawText, which is part of our helper121 object. And the arguments to this function, first off, are Spritebatch, because it needs to be passed in, and then the text we're going to draw on the screen, and then the location where that text will be drawn. So location gets to the heart of what is basically a 2-dimensional array. Your screen is 2 dimensions. It's left to right and top to bottom. X is always considered left to right. Y is always considered up and down. And X conventionally comes before Y. So these are the XY locations. 200, 200. Now if I change that to 0, 0, where would the letter appear? It would appear in the upper left corner, because that is the 0, 0 point for computer screens pretty much everywhere in the world. Let me try. Yeah, you can see that my A appears in the upper left corner. But that teaches us a couple of things. First off, that 0, 0, that is X equals 0 and Y equals 0, is your upper left corner of your screen, or upper left corner of your window. But it also means that when we're drawing letters and we give it a location to draw at, we're giving it the upper left corner of the letter, or at least the first letter we're going to draw. Because if it were any other way, then maybe that A would be clipped off, or we wouldn't be able to see it because it was off the screen. So when we say where we're going to draw the letter, in an X coordinate and a Y coordinate, we're saying where we're going to start drawing the upper left of that letter. So let's stop the program and change it from some letter to something else. No, that's not how you spell aardvark. Alright, let's try it with an actual word. Notice that we're printing the actual word, and we're still starting at the upper left corner, but we're printing an entire word, even if that word is as long as the screen. Right, I'll close the program. And notice also that we don't have to stick with white. Color.white can be changed. In fact, I can change it to black, and we'll see what happens. Yeah, the letters are black now. So what's important to know is that when you're doing color.black, you're doing a system-defined color. And the color object that comes with XNA has lots of system-defined colors. Let's look at them. I'm going to backspace so that I get rid of the period, which is like the has function in object-oriented programming. And then I'm going to add it back. And when I do, we see some of the powerful functionality that Microsoft's tool gives us just for playing along. We've got a nice list of all the members of color. And you can see there really are quite a lot of different possible colors we can choose from. I'm going to choose turquoise, which according to the pop-up is a system-defined color with the value red 64, green 224, blue 208, and full alpha. I'll hit enter and notice that now my line says color turquoise. This is part of the power of this editor that Microsoft gives us, and it's going to take a little time to get used to, and it's going to feel weird because it's going to feel like the tool is doing things and trying to read your mind, and frankly it is. And sometimes it doesn't read it correctly, and that makes everything confusing. But practice makes perfect, and I assure you that these cool features of your editor will come in handy. Fire up the program again, and my word aardvark is now in turquoise, just like I asked it to. So here's your assignment, just as it will be for all assignments in this video series. I have given you base code that does something, an actual program that runs that you can get working. But now I want you to expand it. I want you to apply your creativity and what you've learned with your programming to make it even cooler and do more interesting things. Let me give you a list of the rubric of things that you can do to make this program more interesting. Number one, I'd like you to put multiple pieces of text on the screen, not just one. Number two, I want you to put text in colors other than white. Now we already did that, but I know that you want to play with it and try your own colors out. Number three, I want to see text in a much smaller or larger font. That requires adjusting the sprite font, but I know you can do it. 4, text that moves around on the screen. That's going to require that you take the X and Y arguments of your draw text function and replace the constant values with variables so that you can adjust those variables over time. Number 5, I want to see text that blinks, like blinking on and off. You can do that with a timer variable. Number 6, text that shows a changing internal state, like time left, or score, or lives left, or how close you are to your target. One easy thing to do if you're out of ideas is to make a ticking time bomb value where the number ticks down. And then maybe when the timer ticks down to 0, it can explode. Number 7, I'd like to see text pieces arranged in a pattern to make something visual. Maybe a racetrack, or a maze, or a face. Number 8, text that responds to keyboard input. I want to see you move the letter A around the screen with your arrow keys. Or I want to see you, the bomb change from armed to disarmed because you hit the space bar. And number 9, text that tells a story. Remember, text is very powerful for telling stories. A picture is worth 1,000 words, but if you don't have a picture handy, you can go ahead and write those 1,000 words. Writing a story on the screen, using the fact that you can express yourself with different colors and sizes and fonts of text, is definitely going to add pizzazz. I hope that this first lesson helps you understand the basics of programming and gets you excited about the possibilities of what you can control on your own computer screen. Now, the sky's the limit, and we've just begun. This is just the tip of the iceberg. But that doesn't mean that you can't be excited and creative with what I've given you already. Have fun, and I'll see you next week. Thanks for watching.